Welcome to today's explainer. I am so thrilled to have you here because we are jumping right into one of the most intense, fiercely debated, and honestly, fundamentally important areas of modern intellectual property: software patents. Using real-world case studies and the freshly published 2024 USPTO patents update, we're going to decode exactly what it takes for software to survive the ultimate legal gauntlet. Is your groundbreaking software legally meaningless? It's a harsh reality to face. In the modern software age, you can spend years grinding away on a brilliant idea, writing millions of lines of beautiful code, only to find out some legal loophole makes it about as protectable as a recipe for a peanut butter sandwich. There's a massive, massive gap between a great idea and a legally defensible patent. Okay, let's dive into this. Here's our roadmap. We'll cover the software patent paradox, navigate Alice-Mayo, look at the Adasa hardware winner, the Alice-Mayo software loser, test our challenger, hierarchical scripts, and finally deliver the verdict.
Starting off with Section 1, the software patent paradox, and the very real struggle to protect code.
So, under 35 U.S.C. Section 101, the Supreme Court basically excludes abstract ideas, laws of nature, and natural phenomena from being patented. Why? Because they're considered the basic tools of scientific work. The thinking goes that monopolizing those fundamental concepts would actually hurt innovation. But here's the massive paradox for developers. Software is literally built on logic, algorithms, and math. So how on earth do you patent something that is practically made out of unpatentable abstract ideas?
Moving right along to Section 2, navigating Alice-Mayo, the two-part legal framework.
To solve this paradox, the Patent Office relies on what's basically a strict mechanical trap, the Alice-Mayo framework. It's a two-part test. First, the examiner asks, does the claim recite an abstract idea, like, say, a math concept or a mental process? If the answer is yes, we move to the crucial second step. Does the claim as a whole integrate that abstract idea into a practical application? And honestly, most importantly for software, does it actually improve the functioning of a computer or another technology? So, the absolute crucial point you need to understand is this. Simply taking an abstract idea and saying, hey, do it on a computer, is absolutely not enough to win a patent. No way. The guidance makes it super clear that your software claims must explicitly link your logical algorithms to a physical performance optimization. Essentially, your code has to physically improve the technological environment it runs on. That brings us to Section 3, the winner, Adasa hardware, and hardware-based data structures. In a massive 2022 Federal Circuit win, Adasa established a literal blueprint for how to claim data structures correctly. What they did was, they took a serial number space for RFID tags and logically subdivided it right at the binary level. They used what are called the most significant bits to allocate specific blocks of numbers to different physical encoders. It's like a giant puzzle they perfectly organized. Now, the competitor, Avery Dennison, tried to argue this was just the abstract mental idea of dividing up numbers. But the Federal Circuit completely disagreed. They noted it wasn't a mere mental process, but a hardware-based data structure focused on improvements to the technological process by which that data is encoded. See, this logical subdivision meant encoders didn't have to constantly check a centralized database, which physically reduced communication latency. It wasn't just math, it was a tangible physical hardware optimization. On the flip side, Section 4, the loser, Alice-Mayo simulation, and the visual abstraction trap. This serves as a really powerful cautionary tale. Consider the stark contrast we're looking at here. While Adasa claimed physical block allocations that reduced real-world latency, Alice-Mayo's patent tried to claim a system that let developers build object-oriented simulations using visual graphics instead of typing out programming text. Basically, it was a drag-and-drop visual interface for coding. Seems super useful, right? Well, the Federal Circuit flatly rejected Alice-Mayo's patent. And their reasoning is absolutely critical for anyone in software to grasp. Alice-Mayo argued, hey, our software makes developers faster and more efficient. But the court impartially ruled that improving a user's experience or claiming faster processing speeds that just naturally happen when you run a program on a computer are merely inherent results of applying an abstract idea to conventional hardware. It didn't actually improve the computer's underlying functionality itself. It just made things prettier for the user. All right, Section 5, the challenger, hierarchical scripts, and merging data and logic. Let's play armchair patent judge for a minute with a really fascinating mystery box technology. Inventor Kyle McLean Smith's Hierarchical Script-Database, commercially known as SeedTreeDB. To grasp this somewhat abstract concept, Smith gives a brilliant analogy. He says, it's basically merging an app and a database into one thing. Think of it like this. Traditionally, data, the nouns, sits in a database, and the execution logic, the verbs, sits in an application. Smith's patent collapses that boundary completely, consolidating computational scripts and dynamic data fields directly into the exact same hierarchical tree nodes. Now, what's really interesting about this architectural flow is how a parent node receives an event, and that subsequently triggers the instantiation of a new child node. This isn't just data being passively written to a table. These are active, self-reproducing code nodes, executing their own logic within a sandboxed interpreter environment. It's an entirely dynamic architecture. But, as we just saw with the Simio case, having a really cool logical workflow simply isn't enough to pass the test. We have to look at the deep technical mechanics. This patent utilizes the mathematical foundations of non-halting tiling and geometric scale symmetry. Why go through all that trouble? Well, to specifically prevent deeply nested recursive executions from causing stack overflow errors. This architecture mathematically prevents the host machine's memory from exhausting and crashing. That is a huge deal. And that brings us to Section 6, the final verdict, navigating the 2024 Patent Office rules. Okay, it's the moment of truth. Let's look at the scorecard. ADASA integrated logical bits to physically reduce latency. Eligible. Simio just made visual coding easier without physical integration. Ineligible. So what about our challenger, HSD? Well, it behaves much more like ADASA. By solving a physical memory limitation, literally preventing stack overflows during recursive operations, it integrates its abstract mathematical concepts into a highly practical physical application. Because it fundamentally improves the stability of the host computer, it's highly likely to secure eligibility under Step 1 of the Alice framework. So what does this all mean for us? If you're a tech entrepreneur or a developer, the main takeaway from this explainer is that you cannot patent abstract logical arrangements, and you absolutely cannot patent visual workflows. To survive the patent gauntlet today, your software must be designed and legally claimed with deep technical integration. You basically have to prove without a doubt how your logic directly optimizes the physical system it runs on. I want to leave you with a final, somewhat provocative thought, especially when we look at the 2024 AI Guidance Update. We just walked through exactly how hard it is for human developers to prove their code physically improves a system. But as AI increasingly assists in generating vast new architectures and code bases, how on earth will the Patent Office differentiate between a human's brilliant technical integration and an AI's abstract idea? The landscape of digital ownership is quite literally shifting beneath our feet, and the gauntlet is only getting more complex.